So what we've got here is a titration question straight from Heinemann Chemistry 2, which pretty much demonstrates the kinds of things that can be asked of just a straight titration type question. So this is question 8, and it says the ammonia content of cloudy ammonia was determined first by diluting a 25 ml sample to 250 ml. So already we can see here that we're dealing with some sort of dilution. We're going to worry about this at the very end of the question. We then go on to say that we had a 20 ml aliquot of this solution was titrated with 0.0987 molar hydrochloric acid. The volume of the acid used was 22.18 mils. The equation for the reaction is, we've got our NH3 reacting with our hydrochloric acid to give our ammonium chloride. Now, when we aren't given an equation, the first step that we must take is to actually write out a balanced equation, because often we need to look at the molar ratio in order to work out our concentrations later on. So the first question here is to calculate the amount of HCl in mole used in the titration. Now already, as you can see here and here, we've sort of already defined our variables. So if we have a look at this, what we have is that our concentration is going to be equal to 0.0987 molar, and we know that our volume is equal to 0.02218 litres, because our volume is always given in litres. Now, to figure out our amount of mole of hydrochloric acid, it's simply going to be N is equal to C times V. If we substitute in our values, which we've got up above, and of course we're going to include units because that's just the way we roll. What we get is an answer, as we can see on my trusty calculator here, of 2.189 times 10 to the minus 3. And because we care about significant figures, and we go back to our original question, we look for the piece of information with the least amount of significant figures, and we can see there that it is 3 significant figures. So that would be 2.19 times 10 to the negative 3 significant figures. And of course, we're going to write mole in there. Okay. Our next part of the question is asking us to calculate the amount of NH, and that should say NH3, which I'm pretty sure it did at one point, but it's just rubbed off, in mole used in the titration. Now, this is when we have to go back to our balanced equation, which is just here. Now, we've just calculated the amount of mole of our hydrochloric acid that was present. We now want to calculate the amount of mole of this, which is present. So this is where we look at our coefficient or our molar ratios. And what we can see is the amount of mole of this should, in theory, be the amount of mole of this. So what this actually means is that, let's write B here so we don't get confused. Oh, nice colour. We've got NH3 equals 2.19 times 10 to the negative 3 mole. And the reason for this is because our amount of mole of NH3 is equal to our amount of mole of HCl as established pretty much by this equation here. Question C is asking us to calculate the concentration of NH3 in the diluted solution. So this is the solution that we talked about initially up here when we wanted to dilute this 25 ml to 250 ml. So our final volume that we're dealing with is going to be 250 mils. So to calculate the amount of NH3 in the diluted solution, we simply take our amount of mole. Okay, so let's write C here. Our amount of mole that we established it to be was 2.19 times 10 to negative 3 mole. And what we need to do now is pretty much just divide that by our 20 ml that we had taken out of the solution. Okay, which was our aliquot. I'm just going to write aliquot here, so we just don't get confused. Now, if we type that into our trusty calculators, what we should get is a total answer of 0.1094583 molar, which sucks in terms of significant figures. So really what we have here is 0.109 mole to 3 significant figures. Okay. And that's pretty much how to do part C. Now D is asking us to calculate the concentration of NH3 in the original solution. Just rub out that top bit. Okay. Now in the original solution, we're pretty much told that we have 250 ml of the dilute solution. So what we're going to do is we're going to take our full answer here, because we really don't want to round off unless it's the final answer that we're writing. So what we're going to write up the top here is that our amount of NH3 is going to be equal to our 0.1094583 molar multiplied by our volume of 250 mils, which again is in litres, and the answer that we get here is 0.0273645 molar. Now, as this equals the amount of NH3 in the 250 ml of the original concentration, we now then need to divide this number here by our 25 ml. So I'm not going to write it out again just because I'm lazy. So we're just going to divide by 0.025 litres. Okay, and what we get is 1.094583 molar, and let's round it off because that's just the way we are. Okay, so our final concentration, I'm going to write 3 significant figures here, is going to be 1.09 molar. So 3 significant figures. So that, as the question said, was the concentration of the NH3 in the original solution.